Hello. Chemistry is an equally interesting and a tricky subject. But if learnt with easy techniques, it is considered to be one of the very good career options with its increasing scope. Our today's guest found her love for chemistry and then went on to work in the field of teaching to make chemistry more approachable and easier to learn. Today, we will be talking to Dr. Neeraja Dashputre, who is currently working as a Principal Technical Officer in Education at ISER Pune. Dr. Neeraja completed her undergraduate studies in a reputed institute in Mumbai. Then she obtained a doctoral degree from a very renowned university in the USA. During her PhD days, she recognized her love for teaching and then went on to pursue a teaching and learning program at the same university. Post her doctoral studies, she also worked there as a faculty. In 2016, she joined ISER Pune. Her research interests are in pedagogy development for teaching chemistry. She loves participating in science workshops as a trainer and a delegate. She also likes to interact with students and teachers. She has over 8 years of teaching experience in India and USA. Apart from her passion for chemistry, she loves doing on-wheel pottery and painting in her free time. And today, Dr. Neeraja will take us through various branches in chemistry, will talk to us about different aspects like data literacy, problem solving, communication, and most importantly, traditional and non-traditional career options and scholarships available for those who are interested to work in this field. So, let's start.
Hello, today we are here to discuss careers in chemistry and the different opportunities that you may have after graduating from your 12th standard. Up till now, from 9 to 12 standard, what you have studied in the chemistry syllabus is mainly what are different elements, how they form bonds, how they form different molecules, and then how these molecules function. So the main structure of your syllabus so far is the structure and function of different molecules. When I'm talking about functions, I'm talking about how different reactions happen. So how the nature of different molecule dictates the way they react, and also where these molecules can be used in our everyday life. So to think about it, when you graduate from 12th standard, if you want to do a research career in chemistry, that is, if you want to be a research scientist, you have to be mainly curious about how the world around you is mainly shaped and why it is shaped that way. So why do different molecules function in a different manner? What are the kind of reactions that can be done? How they can be applied in our everyday life? Is the main thought or is the main focus of any research scientist. Now, as we had seen in the last video, chemistry is really a central science. So it is connected to all kinds of different sciences. So it is very well connected to physics. It is very well connected to biology. It is connected to applied sciences also. So medical as well as engineering sciences. And really everything that we use from the moment that we wake up. So let's start from toothpaste and toothbrush to the point that we sleep at night. So everything that we use, everything that we consume, starting from food, starting from various things that we use in the kitchen, various things that we use to clean. So mainly chemicals that fall in the range of paints, plastics, various materials, everything really is centered around chemistry. So when you're thinking about chemical research, remember that there are opportunities in each one of these fields. As a research scientist, your main job is to come up with new theories, your main job is to come up with new experiments, to come up with, let's say, new molecules that can be applied for the purpose that you're really interested in. So just to give an example, let's take the example of COVID-19 pandemic that happened a few years ago. When it started, as chemists, we had very little idea of how the virus really infects you, how the virus really transmits, or what molecules or what medicines can be really used to target this virus. So uh, what was the role of the chemists in those times? They had to come up with new drug molecules, they had to do drug trials, they had to come up with vaccines, they had to come up with materials that can be used for cleaning the surfaces. So if you think about it, chemistry is the science of application. So every time a research scientist is mainly predominantly functioning towards solving a particular problem that we may have in everyday life. Now, as a scientist, you could be the scientist that designs the experiment. You could also be a technician who really works on analyzing the data that the experiment generates, and you could be handling various instrumental techniques in chemistry to really give feedback to the scientists. That, so let's say if you were a scientist who was working on the medicine for COVID-19, you would then come up with synthetic pathways to generate that molecule. You would come up with experiments to test whether the medicine is effective, whether the medicine can be used for all age groups, whether the medicine can be used such that there are no side effects, what should be the percentage when you're really designing a capsule or an injection, how much of the drug molecule should be there, what should be the composition of rest of the drug. So all of these questions would be probably designed by a research scientist. And then as a technician, you would be studying the effect of these things. So as a technician, you would be telling the scientist whether the drug is pure or not, whether the composition of the vaccine that you have generated is the right composition or not, whether the drug trials that were happening, various medical trials that were happening, whether they are generating the right kind of effect or not. So a technician and a scientist basically work hand in hand, and they cannot work individually. That is the main thing I want to communicate here. Now, apart from that, when you think of careers in chemistry, there are, as I said, you could be thinking about physical chemistry, you could be thinking about biochemistry. As I said, that this is now mainly falling in the range of interdisciplinary research. So 10 years ago, if you would have seen, the chemistry, physics, bio were kind of compartmentalized to some extent. But now over the years, what we are seeing is the trend in interdisciplinary research. So you would be probably working on biophysical chemistry, studying the effect of different molecules in a biological system. So let's say a human being, and how they could be modified to generate the right effect. It would be the role of a biophysical chemist. Or you would be working on materials. So for example, if you're a doctor and you want to stitch a wound, what kind of material should the stitch thread be made up of such that it dissolves later on, and there are no post surgery complications? That would be role of a material chemist, to come up with that material. And that's why I'm saying that no longer we are thinking of chemistry as an individual branch, but we are really focusing on the um, different connections that it can make with all other branches. So a research scientist basically comes up with new ways of synthesis, comes up with new materials, but a chemical engineer will take these new methods, will take these new materials to a large scale. So when we think about large scale production of the same vaccine that had to be monitored to everybody in the world, the chemical engineers had to design processes to take this same molecule such that it could be manufactured in bulk, such that it could be stored in bulk, such that it could be monitored for a larger population. Now, if we think about the opportunities that you may have when you graduate, first of all, I wish to focus on post 12th. So, post 12th, there are various degrees in chemistry that you may want to take if you want to be a research scientist. So, one of them is Bachelor of Science, BSc, Masters of Science, MSc, after which you can also do PhD, which is a doctorate study, wherein you actually work on a new research problem and really come up with a solution to an individual research problem that probably there is no information about it in the world right now. So you would be contributing to new knowledge in your PhD thesis. Uh, For all of these, remember that your 12th standard basics are very important. You need to study well. You need to do a good BSc from a good college. So there are various institutes in India as well. You have IITs, you have ICERs now. So IITs is Indian Institute of Technology. You have ICERs, which are Indian Institute of Science, Education and Research. You also have institutes like IISc, NICERs are there now, and various local colleges as well. So when it comes to chemical engineering, we do have colleges that fall in the engineering category. So again, IITs are there. You have ICT, Institute of Chemical Technology. Basically, in India, you have opportunities. Now, the main function of a student to really, seek a place in these institutes is to first of all start understanding chemistry to its core. So, as a student, you should not be memorizing chemistry. Remember, just remembering reactions and being able to recite the chemical reactions that are in the textbook does not mean that you understand them. So, to really understand how different molecules function, you need to start asking the questions why. Why does this particular molecule function in a particular manner? So, let's say carbon, the standard statement in the textbook is carbon likes to form 4 bonds. Now, as an information, you would like to remember it as carbon likes to form 4 bonds. But more than that, now the bigger questions are, why doesn't it form 5 bonds? Why doesn't it form 3 bonds? If it forms 3 bonds, what should be the structure? In what circumstances, in what conditions can we get the carbon to make 3 bonds? And so on and so forth. So, you need to start asking questions of why rather than what, if you want to excel in the chemistry research. Now, there are some other non-traditional careers, I would say, apart from research scientist and teaching, that are there in chemistry. One of them is, let's say, a toxicologist, wherein you monitor different toxins. You can really give guidance about the level of toxins that should be there in the environment. You could be working on environmental chemistry, so coming up with really understanding how climate change and global warming is affecting and the environment, and really coming up with ways to lessen the effects of global warming. You could be working on the energy sector, so you could be working on various new ways to really come up with energy resources. For example, fossil fuels, as we all know, is no longer the best mode to store energy and to consume energy. So, what are the other ways? What are the renewable sources of energy? Can we come up with better energy storage devices? Would be the job of an energy chemist. You could also be working on various other chemistry related professions, I would say, which is a patent attorney. You could be working on as a science illustrator or a science communicator. You could also be working in the domain of policies. So, what are the different policies that should be governed by the Indian government, or by any government for that matter, such that the proper disposal of chemicals, proper usage of chemicals happens. So, if you think about it, post 12 standard, my only suggestion would be to not narrow your focus right away, but really explore different opportunities that are there, because chemistry, as I said, is really a central science. You can, if you, for example, like computer science, and if you like, mathematics and algorithms for that matter, you could be working on a field called as chemical networking, which is coming up in the last 10 years by a large extent, is to come up with AI, the artificial intelligence based chemistry platforms, or virtual labs, or different platforms that basically engage with a computer scientist within you and the chemist within you. Now, to get into these institutes and to start your journey as a research chemist, you would have to do BSc, MSc, PhD, postdoctoral studies, as I was saying. In order to get into a good DSc program, what you need to do is basically focus on doing well in your 12th standard. Again, focusing on the fundamentals of studying sciences is the main crux. As I said, asking why, understanding the science or the subject that is written in your textbook and not really memorizing it only would be the first task as a student. After that, in order to get to these institutes, there are various entrance exams that are mandated. For IITs, you have joint entrance exam JEE. For ICERs, you have um joint entrance exam, that is the ICER entrance exam for all ICERs together. Um, Again, the JEE score can be used for various ICERs, NICERs, as well as other big institutes to get into. So when you're studying for them, just focus on really understanding how molecules function, and how their structures basically dictate the way they function. Apart from that, when you get into a BSc program, remember you need to do well in your BSc to get into a good MSc and so on and so forth. But more importantly, there are various scholarships that are available. So, Inspire Fellowship is one of the fellowships that is doing really good work for students who need scholarships. You could apply for them. Again, it all depends on how well you do in your 12th standard, how well you do in your BSc, and so on and so forth. So, if you're scoring well, if you're studying well, then you are eligible to apply for all these scholarships, and then really you can make use of that to get to a better position in your career. So when you're thinking about future opportunities, remember that, as I said, it's a very interdisciplinary field. You can graduate in chemistry and really work at any interface of various sciences, engineering, and medicine. So thinking about future opportunities, the main thing I would say is do not narrow your focus right now. So don't say that I want to only do research in environmental chemistry. You may later on discover that you like environmental chemistry, you like to study how climate change happens, but you may like to also communicate sciences. So you may like to work as an environmental chemist who works in a newspaper, or who works to really communicate the science of this climate change to the public. Or you may be working on policies. You could be an environmental chemist who designs policies at the state level, at the national level. So just don't narrow your focus. Start studying chemistry from your BSc. As I said, you would be starting from studying organic, inorganic, physical chemistry, but later on you will delve into much more connected branches. So biophysical chemistry, bioorganic, bioinorganic, various kinds of interdisciplinary sciences you would learn, and you would probably find your liking, or your calling when it comes to chemical research. So that's my only advice to people doing chemistry, or people trying to graduate with chemistry degrees, is really opportunities are there if you keep your mind open, if you prepare yourself for them. So when it comes to opportunities in research, for that matter any research, remember that you need to learn how to communicate well, you need to learn how to write well, you need to learn how to talk well, how to design or communicate your science with larger audience. So if you can work on these soft skills alongside, you need to have a good data literacy. So when you're working with another branch or another scientist, remember that science is not something that a scientist does individually. It's always a team effort. So when you're talking with other scientists from different branches, you should be able to understand what they are doing. So you need to understand their data, how to read a graph, how to read, let's say if you're given large amount of data, how to consolidate it and how to make meaning out of it. So all of these skills are really some skills that are needed irrespective of any branch that you choose to. So as you focus on learning the chemistry, also focus on data literacy, also focus on communication skills, also focus on problem solving skills. If you start looking at the bigger picture, you will realize that both of these skill sets, the content skill set of chemistry as well as the content skill set of these 21st century skills, as we call it, problem solving, data literacy, various kinds of communications, they go hand in hand, and both are needed to do well in your career. So All the best to everyone, and I hope you will follow your path in research chemistry.
Chemistry, a central science and science of application, since last 10 years functions as an interdisciplinary science. Opportunities post 12th, Bachelor of Science BSc, Master of Science MSc, Doctor of Philosophy PhD in Chemistry. Careers in chemistry, traditional careers: 1. Research scientists, 2. Research technicians, 3. Teaching. Emerging opportunities: 1. Toxicologist, 2. Environmental chemist, 3. Energy sector, 4. Chemical networking, 5. Chemistry related professions, patent attorney, science illustrator or communicator, policy making, etc. For careers in chemistry, student needs: 12th standard basics should be very clear, understanding of molecules and application in daily life more important than rote learning, soft skills such as communication, problem solving, data literacy. Institutes and entrance exams: the Indian Institutes of Technology IIT, Indian Institutes of Science Education and Research ISER, National Institute of Science Education and Research NISER, the Indian Institute of Science IISc, Institute of Chemical Technology ICT, local colleges. Entrance exams are Joint Entrance Exam JEE, ISER Aptitude Test IAT, National Entrance Screening Test NEST, etc. Scholarships available for students: example, Inspire Fellowship, requires good academic performance in 12th and BSc. Future opportunities: don't narrow your focus right away after 12th standard. Opportunities available in multiple disciplines and interdisciplinary fields. Keep open mind and explore various options.